Last week you've implemented a Hello World program, and for that little program there is a surprising amount of detail that are there to cover. So this week we're going to dig into all of those details and uncover how that small but very useful for educational purposes program actually works. Right, let's start by first implementing the same program again. It's very quick, so please bear with me. For that we will open a terminal and I will just add a new file in a temporary folder. Let's actually create a folder there. So I'm already in the temporary folder right now and I want to create a folder hello and let me navigate to this folder hello. And now I want to open a file hello cpp in my text editor. I will be using VS Code here, but you can of course use any text editor that you'd like. Cool, so now we have this file open. Let's quickly implement that program again. We need the main function, we need the put s function. Let's actually print hello world, and we will return a 0. Now let's save it. Let's see that it's actually saved and let's compile it. We want the output file to be the hello and we want to provide the hello.cpp. I would like to add one more flag here, and this flag will be the -std equals C++17. We will be using this flag all over the course just to make sure that we're always compiling with the C++17 standard and not something else. But it doesn't really change much for us for now. Cool, so we run this program and we see that now we have a binary hello in our temporary folder, so let's call it, and it prints hello world. Hooray! So we're back at where we left off in the last video. By the way, if you like these videos, then please do like them and subscribe to the channel and, you know, ring a bell to be notified whenever I do get the time to upload the new video. And you can already see that there is actually quite a lot going on the screen. There is a lot of things that you can see in this pretty small program already. The things that you might notice are actually some keywords. So for example, return is a keyword and that's why it's highlighted in a different way. Int is a keyword. It actually means the type, like an integer type. We will talk about the types in the coming videos, but for now it's important to understand that it is actually just an integer type. There is also this hashtag with include. And then there is a bunch of other things like main and put s that have different colors and a bunch of brackets. So all of the brackets that you'd like, the curly brackets, the round brackets and the angle brackets, all in one go. And then there is a string, like the hello world string and the number 0, right? So a lot of things going on there. And let's dig into all of those. The first thing that is important to understand here is that C++ is a programming language that lets us write words that we can read and understand, and then we use a compiler to translate these words into something that the operating system can understand, and finally the processor can actually process, right? So keep that in mind when we think about even such a small program like this. So all of the words like include, main, int, put as, return and whatnot, they're just words that have to make sense to us. Arguably sometimes they don't, but hopefully we'll comb through this. Everything that you see on the screen in this Hello World program helps the compiler split the code into certain parts that it can then process and make a binary out of. And these things are split by whitespace. There is a whole bunch of whitespaces on the screen here. So there is like the new line from say here to here. There is just spaces all over the place here, and you can also see some spaces that make the code look a little bit nicer for us. But generally speaking, spaces are only important to split the different words between each other. So, for example, if I don't have a space between an int and the main, then it becomes one word, int main, which means nothing to the compiler. It's just a set of letters stacked together. It also means not that much for us in this particular case, but it might in some other case. So if we have this int main, then the program will not compile. And we can try that. Let's try to... Oh, yeah, we have to save this. That's a common problem, that you forget to save your file. Well, actually, I forget to save my files. So, cool. Basically now we have some error, and at this point it's not important what this error is. We will be looking into many more errors and explain what they mean later in the course. But for now, the main part is that now the compiler is confused, it doesn't understand what we want from it, so it can't compile it. Perfect. Let's return it back, let's save the file, and now we can talk a little bit more about the whitespaces. There is actually quite a few, and the fun part about C++ is that it really doesn't care about whitespaces as long as they separate the different parts of the language. So, for example, if I add more spaces here, or if I add some spaces there, and if I say put this return over there, and maybe the bracket also here, and maybe split the int and the main. So mostly C++ doesn't care. I can also add more white spaces over here, and maybe even add a couple more here. Right, so I can save this, and now if I actually, let's clean the terminal, if I now compile the code, it still compiles, right? So it's a completely valid program, and it still prints hello world. So C++ doesn't care about white spaces. But now it is much harder for us to read this code. In the end of the day, we are the ones reading the code, and the code is going to be read many more times than it's written. It's written once, and hopefully it's going to be read a lot of times by your colleagues or whoever wants to read your code. So we really have to think about making our code readable, and white spaces are a big part of that. And if you ask 100 people on how many white spaces should be somewhere, where should be the curly brackets and everything else, you're going to get probably 100 opinions. And that's why we now have a tool for this. This tool is called clang-format, and you can apply it to your code to structure it in a way that fits a certain pattern. You can call it, it's just a terminal program again, so I can call clang-format and I can provide it my hello CPP, and what it does, it prints what it will do to this file, for now just to the std out of my terminal. But if I don't want it to print it out in the terminal and I actually want to change the file, then I just have to provide the -i flag, and then it will update the file, and you can see that the file is back to its original form, where everything is neatly structured together. You can set this up the way you want, and there is a way to configure it by using a so-called .clang-format file. Let's not go into details of this right here, but generally speaking, it's just a collection of settings. And again, if you ask 100 people, you will probably get 100 different suggestions on how this file should look like. And of course, I have my own preferences that I will just link in the description below and leave on the slides afterwards. But the main part, I hope, is clear, that white spaces are not important for the compiler, but they are important for us. And let's just use clang-format. This is the standard tool. Everybody uses it wherever you go, with whoever you work. They should be using clang-format. If they don't, they really should, but probably they do. You also see a lot of brackets in this file. And every bracket has its own meaning, and they're used for different use cases. We will not cover all of the possible use cases that every bracket can be used for, because it's going to be very tedious, and I don't really think that this is the way to teach C++, to just overwhelm you with information that is just too much and not very interesting. So just believe me that they're used for different things. We will cover some use cases now, and we will cover more use cases later. Right, so brackets are important. We will be talking about them a bit later. We will be talking about different symbols though. If you look at this file, you can see that there is clearly a couple of symbols that definitely mean something to the compiler. And we will start with the semicolon symbol. So the semicolon just splits the different statements in C++. In most of the cases, you will have a semicolon at the end of most lines, unless there is some bracket in there, because the brackets can kind of serve the same purpose of splitting the statements. So for now, just prepare to type a lot of semicolons in your code. Another symbol that you might be used to from different social media is the hashtag. So the hashtag like here, like in the include. And this is a special symbol, and what it signifies is it signifies that this is going to be a preprocessor directive. Now, you might wonder what is a preprocessor directive, and it sounds very scary, but it actually is not. A preprocessor is basically just a text replacing tool that runs before the compilation begins. So whenever we compile our program, the first step that happens is that preprocessor runs through it. It finds all of the statements it can understand. They usually start with the hashtag, and then it replaces them purely in textual form with something else, depending on the statement that it sees. In this particular case, it will see the hashtag include, and the hashtag include basically will replace this line with the content of whatever is stored in this file. Like the full content of that file is just going to be copied over here, and that is what is going to be compiled. And we can actually see how it works. But before we jump there, we have to talk a little bit about functions. Again, this is a huge topic. We're going to be covering this in multiple videos. But in this video, I just want you to understand what a concept of a function is without really going that much into details. So, we actually have two functions in this code. We see the putS function, and main is also a function. So what is a function? A function is just a convenient way to store operations together, both for us and for the compiler. Let me explain. So when we write code, we basically write high-level instructions of what we want the code to do. And we can pack those instructions into a function if they have to happen, always happen in the same sequence, right? So that would be a function. In our case, we just print something, but in order to print something on the screen, there is actually a lot of things that have to happen under the hood, and all of those are packed into a function, something like a putS, right? So I hope that makes sense. But the same thing happens on the compiler side. So whenever the compiler compiles the code, it puts it in the binary form. Now, we have to take a step back here and talk about what is a binary form. Essentially, it's just a collection of instructions that the OS can interpret and send to the processor to be processed. That's it. So a binary file is just a file of a certain format that the operating system can read and process the operations stored as commands in that file. It's as simple as that. Now, whenever we write a function, not always, but in most cases, the compiler can then take this code that it generates for this function, put it in some place in a binary, and whenever this functionality has to be called, it will just reference the same part of the binary file. And then you can expand it to basically explain how the whole binary gets called and works by basically thinking that it has some form of an entry point. This is where the main function gets compiled to. And then whatever you call from your main function will just have a reference to wherever it is stored in the binary file. If you write everything within one main function, it will be just a sequence of operations, but if you have functions there, then they will be referenced in whichever position they are in the binary file. I hope it all makes sense, but we will be talking about this a lot more in the future. Now, this allows us to write our own very simple function. It's not going to be a very useful function because, again, I don't want to go into too much detail right here, but it's going to be a function nevertheless. And whenever we write a function, we start with the type that it returns, then we call it the way we want it to be called, and let's call it print hello world function, and then we put the brackets. The brackets signify the function. We could put some parameters in there, but I don't want to talk about the parameters right now, so for now we're gonna leave it empty. And let's just print the put as hello world in there. Perfect. That's everything that we wanted from it, and we just need to now call the function. To call the function, we just type it. We also use the brackets to signify that this is a function call. Let me remove a couple of empty spaces just to make it fit on the screen. And now if we save it and compile it, we can actually get both of the hello worlds printed to the screen. Right, so fairly easy. Like, the function is actually pretty easy. And this allows us to easily talk about the include preprocessor directive. We can now see that whatever it does, it just replaces textually some things in our code. And for that, we will have to compile the code with a little bit of more trickery to it, and we will add another flag to the compiler. We will add the flag, it's called save temps. So now that we've compiled it and we can ls the things that we now have in our folder, you can see that we have more files now. Before we just had the hello, and now we have a lot more of those. What we're interested in is we're interested in the file hello.ii. This is the file that basically is generated after the preprocessor is run. And then this one is passed to the compiler to actually generate some binary code from it. So it has all of our textual replacement in it. And now we can see, if we just scroll a little bit up, you can see that it ends with our program, but before that it has a lot more code in it. You know what, let's open it in the editor so that we can see how much code there is. And you can see it's a pretty big file, because it just copied the whole stdio.h. And if we scroll down to it, we will see that it ends with our small program hello world, but now there is a function put as somewhere in here. Let's actually search for it. So I can search for it up, and you can see that it's defined as a function. Again, the details here are not important. The main part is that it is found in this file, so we can use it. Perfect. At this we can close the hello.ii, and I hope that I got you convinced that this is basically what the includes do. They just take the line in here and they replaced it with the contents of the file. There is a lot more preprocessor directives that we will be talking about, but for now the include one is more than enough for us. Perfect, so at this point I will just remove this function. We don't need it, and it just eats up the space. What I didn't talk about, and I want to talk about it here, is that you can also type things like this, and these are just comments. So they mean nothing to the compiler, and actually if we compile the code with the save temps option and we open it in the editor here, you will see that the final program that gets to the hello ii file, it doesn't have our comment in there, right? So you can see that the comment is here in the original file, but not in the hello.ii file, which makes a lot of sense. The comments are just that. They are for other human beings to understand our intent, and they get completely removed from the code when the code gets, or even before the code gets compiled. So if you want to explain something not intuitive to somebody who will read your code, use comments in there. And with this, I think we covered everything that was there to learn from this small Hello World program that you've written before. And just to make sure that this solidifies in our brains, there will be a homework about this. So you will have to write the hello world program, maybe change the string a little bit, and then upload it to your repository so that the bot can evaluate, compile it and run it, and actually check that it outputs the hello world string or whatever string I will ask you to output. Cool, and this opens us up for going deeper and into a little bit more complex things and actually writing something useful in C++.